Assalamu alaikum. We have to discuss here the two important things. They are angle of friction and angle of response. Okay. We are discussing physics of class 11th. Unit is laws of motion. Right. Let us first take angle of friction. Okay. Angle of friction. Right. Before moving to the definition of it, let us move to the diagrammatic explanation. Okay. See, if this is a plan, okay, a body lies on it here, this is the body on it, okay. Let me apply the force to this body. This is force, applied force, okay. I am applying force in forward direction, and we know here the friction arises, and friction arises at the surface of contact. Okay, here is the surface of contact between upper body and lower surface. Okay, this is the force of friction, and it acts in the opposite to the applied force. If applied force acts forward, then friction, force of friction acts in backward direction. Okay, so this is force of friction. Let me repeat it. If applied force is in forward direction, then force of friction acts at the surface of contact in backward direction. Okay, here. Next point, normal reaction. See, here is the weight which acts downwards. This is the weight of this body, right? Acting downwards, force, okay, acting downwards. Then normal reaction, you know, it is the force acting opposite to the weight. So here it is normal reaction, or it denotes normal reaction. Okay, then let us get the resultant of these two forces. One force is this normal reaction force, and next force is this frictional force. Okay, I am not talking now of this applied force. Now I am taking into consideration only normal reaction force and force of friction. Okay, let us get its resultant. By law of vectors, we can get the resultant of these two, total of these two. How we can get? Let us draw this parallelogram. This is a parallelogram, okay, of these two. Then draw the diagonal of it. This is the diagonal. This diagonal of this parallelogram, it is the resultant of these two. This is the resultant. So this diagonal is the resultant of force of friction and force of normal reaction, right? Since we are going to take angle of friction, now we can get it. Now see this angle here, this angle theta, this is angle of friction. So what is now the angle of friction, right? We can say this angle of friction is the angle which the resultant of, this is the resultant of what? Force of friction and normal reaction. Okay, which the resultant of force of friction and normal reaction makes with this normal reaction force. Okay, let me repeat it. See, this is the resultant of this and this, of force of friction and normal reaction. Okay, resultant force. Then this is the normal reaction force. The angle between these two is the angle of friction. Okay, so what is now angle of friction? It is the angle between the resultant of force of friction, normal reaction, with again the normal reaction. Okay, let me write down it. Here it is, the angle which the resultant of friction and normal reaction, resultant of friction and normal reaction, okay, make us with the normal reaction is called as angle of friction, right? So this was regarding angle of friction. Let us move to its mathematical concept. See, let us take the triangle ABC. Let me take the triangle ABC. No, AOC. Sorry. In triangle AOC, okay, tan theta is equal to perpendicular by base Here perpendicular is the side opposite to the angle, meaning it is CA. It is perpendicular by base. Okay, perpendicular by base, we know tan theta is equivalent to, and since this CA, it is equivalent to OB, because in parallelogram opposite sides are of the same length. CA is equal to OB, so CA can be replaced by OB, and this is again the same. Okay, so here OB is equal to the force of friction. Okay, and OC, it is equal to the force of normal reaction. OB replaced by force of friction and OC replaced by normal reaction. By law of friction, we know force is equal to mu r. This is law of friction. Okay, then by using this r and r, it gets cancelled, we get tan theta is equal to mu. Mu is the coefficient of friction. So we can say in the next way that coefficient of friction is equal to the tangent of angle of friction, right? Now the next topic we are going to discuss is angle of response, okay, or we call it as angle of sliding. Okay, let us understand it. See, if we have this like figure, okay, and a body is on it, have concentration to this point. This body is at rest on this surface, okay. Let me increase the angle, this angle, let me increase it, meaning let me keep it up like this. If I will go on increasing the angle, okay, a time will reach when this body now starts, just begins to slide down. Okay, at this condition it is not sliding down, it is not coming down. Okay, but if I will take it to this, let it is not again moving. If it will, I will reach the angle, make the angle like this, meaning I will keep it up like this, then the body now just tries to slide down, okay. Then at this time, when the body just now starts to come down, to slide down, because the slope of this plane got increased, okay. Now at this time, this angle is called as angle of response. Okay, let me repeat it. What is now the angle of response? It is that angle at which this body on this inclined plane, it just starts to slide down. At that time, the angle between this plane on which the body slides down and the horizontal is called as angle of response, right? Here I have written, it is defined as a minimum angle of inclination, okay, but minimum of a plane, okay, with the horizontal, of the plane with the horizontal, this angle, such that a body placed on the plane just begins to slide down. When it starts to slide down, then at that time the angle between this plane and the horizontal is called as angle of response or angle of slide. We denote it by alpha. Now let us take some mathematics. Here mg is weight of this body. Okay, this weight always acts downwards to the center of the earth. Okay, but this weight here has two components. One component is mg cos alpha, and next component is mg sin alpha. Vertical and horizontal components, which you know, mg cos alpha. But see, this mg cos alpha, it acts downwards, and here normal reaction acts upwards. So these two balance each other. Meaning, this is equivalent to this, because when the two forces act in opposite direction and they keep the body in rest, so we say these two forces are equal, okay, but opposite. So this magnitude of this normal reaction, it is equal to magnitude of this component, okay, because these forces keep the body in rest. Yeah, here in this situation, okay. So we can write this R is equal to mg cos alpha. And here the next force, see, this time the body is acting to this way, meaning the force acts in this way. Then why will be the direction of friction? It will be opposite to this, meaning here in this way. Here this is the friction at the surface of contact. Okay, then this frictional force, it is balanced by this mg sine alpha. So we can write F is equal to mg sine alpha. This force and this force, they two get balanced with each other, and these two forces get balanced with each other. Okay, in this way, for this sake, I have kept this equal sign in between. Okay, so by dividing these two, we get F by R is equal to this sine alpha by cos alpha, it is equal to tan alpha. So we again got this mu is equal to tan alpha. In the first case, when we were taking into consideration angle of friction, at that case we got mu is equal to tan theta, because theta is angle of friction. Okay, and now we got again mu is equal to tan of alpha. So we got the two equal and same relations, two equal relations, not the same but two equal relations. By comparing these two, this they get cancelled out, we get theta is equal to alpha. So this is angle of friction and this is angle of response, so they are one of the same things. So we can say that angle of friction is always equal to angle of response, right? See, it is a numerical problem here. A block of wood rests on a plank. This is the block of wood. It rests on the plank. Okay. The coefficient of static friction between block and the plank is 0.6. Here the coefficient of friction mu, it is equal to 0.6. Okay. If the angle theta between plank and the horizontal is gradually increased, here it is the this is angle theta here, or I can write it since we denote this angle by angle of response alpha. Okay, let me denote this by alpha, because if the angle theta between the plank and the horizontal, this is the angle between plank and the horizontal. So here it is theta, but if we represent it by its actual term, then that will be alpha. Okay, so theta is actually the alpha. Between the plank and the horizontal is gradually increased. If I go on increasing it, this angle, like it is in this way, then I will increase it. Okay, at what value of theta, this here now theta or alpha, okay, will the block start to slide down? We have to find out that angle at which now if I increase it, now the block it slides down. Sample by law we got it this coefficient of static friction, it is equal to tan of the angle of response. Okay, here angle of response theta or alpha. See, I am writing theta or alpha, and we got it that these both angles are of equal value. Okay, so alpha, how much is it? We have to calculate. Okay, but coefficient of friction is given, it is 0.6, right? So by replacing this by the values, I got this alpha is equal to tan inverse 0.6, value of this is 31. So if I will increase the angle beyond 31 degree, then this block it will now start sliding down. So let me repeat, above 31 degree angle of this angle of response, meaning the angle between the plank and the horizontal, the block will now slide down. Okay, so this was related to angle of friction and angle of response. I think you would have gone and you have got the topic. Thank you. Assalamu alaikum.